Okay, topic 5 is over the introduction to linear graphs. Okay, yeah, introduction to linear graphs. We're going to go over the concepts one-step equations, so how to solve an equation with only one step. How to solve equations in multi-steps, so that's just more than one, so 2, 3, 4, how many steps it takes. Third concept, coordinate graph and plotting points. So just remembering how we label a coordinate graph, which coordinate is 1 versus which coordinate is 3. And then lastly, getting y by itself, so we can form y equals mx plus b. So that getting y by itself is the concept of literal equations. And this y equals mx plus b, this is slope, intercept, form. So we're going to learn about all the forms of linear equations, and you're going to have to be able to remember which is which, especially if I ask, okay, solve this problem and then put it into standard form. Solve this problem and put it into slope, intercept form, so on and so forth. So concept 1 is one-step equations. One-step equations mean we only need one operation to get the variable by itself. So for these examples, it wants us to name the operation and then solve. Okay. So looking at number 1, we have 26 equals 8 plus x. What is the operation to get x by itself? Subtraction. So I'm going to write subtraction. Okay. And then I'm going to actually solve it. So if we're subtracting that 8 to both sides, and we get x is equal to 18. Okay, since number 3 is already up here, we have negative 104 equals 8x. What's the operation to get x by itself? Divide. Okay, so we would have to divide both sides by 8. And we get x is equal to negative 13.
How does it word it again when it's asking for the... Can I see what it says up there?
Oh, yeah. For the name.
Operation needed. Okay.
Name. I'm not going to have you do that on a test. This is just for the notes.
Okay, cool.
For the test, I'm just going to give you a problem, and you're just going to have to solve it. Okay? Again, since these are the notes, I have everything broken down a lot. Okay, what would be the operation to get x by itself on 2? Add the 9. So we're looking at 2, so add the 9, so it's add. If we add 9 to both sides, we get x is equal to negative 4. For number 4, what's the operation? Multiply. And what are we multiplying? So if we multiplied by the reciprocal, that would actually cancel out the x too. We don't want to cancel out the x. The 18. So we're going to multiply both sides by 18. When we do that, we get x is equal to negative 108. Okay, so if we have our x in the numerator and a number in the denominator, you always multiply both sides by that denominator so they cancel out. What's the operation for 5? Add, and what are we adding? 15 to both sides. So we get x is equal to negative 2. It's negative 17 plus 15 is negative 2. And then lastly, what's the operation for 6? Multiply, and what are we multiplying? 4, because it's in the denominator. We want to get it canceled out, so we multiply both sides by 4. So we get x is equal to negative 52. Okay, and again, this concept is just seeing if you remember what operation we need to use to get x by itself. For the next concept, we're going to be using multiple operations. So in this case, we're not going to label which operation we're using. We're just going to start solving step by step. So for number 7, what do you think we do first? Like terms. So we have this negative 4x and this negative 6x. So that combines into negative 10x. Now we have a one-step equation. So what do we do to get x by itself? Divide by negative 10. We get x is equal to 2. Okay. Number 8, what do you notice about this problem that's different?
Both sides have the x.
Good. Both sides have an x and both sides have those constant numbers. So in these type of problems, we're going to have to determine which side we want the x's to go and which side we want the numbers. I always just have my variables go to the left and my numbers go to the right, because when we write our problem, we always write x equals. Okay? So if I was moving all of my x's to the left, what would I have to do first?
Add 5x.
Add 5x. So I get 6x plus 5 is equal to 5. I just brought down those numbers. Now I have my x's to the left. What am I going to do with my numbers?
Subtract 5.
Subtract 5. So I'm moving that 5 that's on the left over to the right. And I get 6x is equal to 0. And then what's my last step?
Divide by 6.
Divide by 6. Anything 0 divided by any number is 0, so I get x is equal to 0. Okay. As we're working on these problems, you can determine which side you want your x's to go on, which side you want your numbers to go on. But for these examples, I'm always going to put my x's to the left and my numbers to the right. Okay. Any questions so far? Okay. Let's go ahead and look at number 9. So again, I'm going to put my x's to the left, numbers to the right. Draw my line through my equal sign to show that these are my two separate sides. So if I'm moving my x to the left, what am I going to do first?
Subtract 7x.
Subtract 7x. So I get x minus 2 equals negative 9, because I just brought everything else down. And then what's my last step? Add 2 to both sides, and I get x is equal to negative 7. No matter which side you end up choosing to move your variables or numbers, you're going to get the same answer always. Okay. Let's look at number 10. On number 10, we have something that we have to do first before we do anything else. What would that be? Good, that distribute. So we're going to distribute that negative 4 first. So I have negative 4 times 1, which is negative 4, and negative 4 times negative 6x, which is a positive 24x. I'm going to go ahead and bring down the other side of my problem as well. So I have everything on the same line. Okay. Once I distribute, what's my next step?
Put the x's on the left side.
Good, so I'm going to subtract this 24x. And then what happens to my x's? They cancel. So I'm left with negative 22 is equal to negative 4. Is this a true or false statement?
False.
False. So since this is a false statement, what do you think my answer is? No solution. If you get a false statement, then your answer is no solution. That means there's not an answer for this problem. Okay, and that's only if you get a false statement. What do you think would happen if we got a true statement? So for example, if we got negative 22 is equal to negative 22, and this is a true statement, what would our answer be? No, so false statement means no answer at all. So true statement should mean multiple answers, which is another way to say what? You guys seen this? Infinite solutions. Many solutions, infinite solutions, okay? So this is just a note that if you see something that is a true statement, your answer is infinite solutions. Okay? Number 11, what do you think we got to do first here? Say it a little louder. We're going to multiply, but we're going to multiply by what? 1 plus x. Good. Whatever is in that denominator is what we're going to multiply, both sides by. Okay. When we do that, that 1 plus x in the denominator cancels. And so we're left with 3 is equal to 2 times 1 plus x. What are we going to do with that 2? Distribute. Good. So we have 3 is equal to 2 plus 2x. Okay. I still want my x's over to this side and my numbers to this side. So what am I going to do?
Subtract 2x.
Good. Subtract 2x. That's going to move it over to the side that I want it. So I have negative 2x plus 3, because those are not like terms. I cannot combine them, is equal to 2. What's my next step?
Subtract 3.
Subtract 3. And I get negative 2x is equal to negative 1. What's my last step?
Divide by negative 2.
Divide by negative 2. And I get x is equal to 1/2. Why is it positive? 2 negatives make a positive. Good. That's a 1.
Would you accept 0.5 as the answer?
Yeah, I would accept 0.5. Okay. Number 12, the last one for this concept. We're going to have multiple things we have to do in number 12 first, and that includes what?
Distributing.
Distributing. So I'm going to distribute that negative 5, then distribute that positive 5, and then start solving my problem. So I have negative 5 plus 25x, that's from the first part that I distributed, minus 40x minus 10, that's from the second part, and then I'm bringing everything else down with my x's on one side and my numbers on the other. Okay? So before I start bringing over my x's and my numbers, what do I need to do first?
Common.
Like terms. Good. So I have the x's on this side and the x's on that side, and then my numbers. So that means on the left side, I have 25x minus 40x, which is negative 15x, and negative 5 plus negative 10, which is negative 15. And on the right side, I have negative 4x minus 8x, which is negative 12x. Okay. Now I can start bringing my x's over to the right side. So what am I going to do?
Add 12x.
Add 12x. I get negative 3x minus 15 equals 0. Now what? Add 15. I get negative 3x is equal to 15. Last step. Divide by negative 3. And I get x is equal to negative 5. Any questions on, what was this concept? Multi-step equations. Next concept is coordinate graphs and plotting points. So it says label the quadrants. In which quadrants are the values of x positive, which ones are negative, and what about y? So first, we're just going to label this coordinate plane. So if I had to label where 1 starts, where is that going to be? First, top or bottom?
Top left.
Yep, and then left or right? Right, so this is quadrant 1. Okay, and then we go counterclockwise. So 2, 3, and 4. And I always write those quadrants in those Roman numerals. 1, 2, 3, 4. Okay. So then it's asking us, in which quadrant are the x's positive? So the x's are positive in which quadrants? 1 and not 2. 1 and 4. Because remember, when we're talking about the positive x's, that's this point right here. All those points. And that's only shared by 1 and 4. Okay, so quadrant 1 and quadrant 4. When are the x's negative? 2 and 3, because we're looking at this side now, and that is shared by quadrant 2 and quadrant 3. Okay, now y's. Where is the y's positive? 1 and 2, because right here is where the y's are positive, and that is shared by quadrant 1 and quadrant 2. So 1 and 2. And then lastly, where are the y's negative?
3 and 4.
3 and 4. So again, that's this part of the graph, and that is shared by quadrant 3 and quadrant 4. So we're going to keep that in mind when we are plotting our points. So a coordinate point is written as x comma y, where x is the x values on the horizontal axis and y are the y values on the vertical axis. So on these examples, it wants us to plot the points and connect them. Once we connect them, we have to determine if the function is linear. So how would we determine if a function is linear? What would the graph look like? A line, okay? Any type of line. So that line could be going off to the right, it could be going the negative direction, it could be up and down, or side to side. Any type of line that is a linear function. So I'm going to go ahead on number 13 and plot these points. So we have 1, 0, so 1 on the x's, 0 on the y's. 2, 2. 3, 4. And then 4, 6. Okay, so those are all of my points. I am now going to connect these points with a line, and when I do that, I'm going to make that line go all the way top to bottom with arrows on either side. Okay. So is this a linear function, yes or no?
Yes.
Yes, because remember, linear function means a line. So this, yes, it is linear. Remember, when plotting these points, we are looking at x's, then y's. Okay. So again, I'm going to start plotting the points on 14. So I have 3, 1. 6, 4, 9, 5, and 12, 7. So 12, 7 is going to be a little off this graph. Okay. Notice that these points don't make a straight line. If I was to connect this, I could say it's something like this. Yeah, there's that little curve right there at the point 12, 7. So since it's not a straight line, is this linear? No, it's not linear. Okay, and if you are having trouble plotting these points and you need the extra practice with plotting points, I finally added all the videos on there from when I taught Algebra 1 at high school level. That breaks down the notes even further than how I'm breaking them down now. So there will be notes that are just on plotting points and just on finding slope and so on and so forth. So that'd be extra resource in case you need it. So for 15, again, plotting these points. So 1, 12, so that's going to be off my graph. 2, 7, 3, 4, 4, 3. Before I draw my line, does this look linear or not? Not, because look, this first point is not lined up, so it's going to have that curve in it. So it is not 100% linear. So this is not linear. Okay. So again, this concept, we're just practicing plotting points. So for 16, we're plotting -2, -4. -1, -1, 0, 2, and 3, 11. Does this look like it's going to be linear? Yes. This one looks like it draws that straight line. So yes, it is linear. Okay. Number 17, I'm plotting these points. So -2, -17, that is going to be way off the graph down here. -1, -11, 0, -5, and 2, 7. What do you guys think? Linear or not linear?
No.
No, why? Why would you say that?
It starts sloping at the end.
Good. Towards the bottom, it looks like it's starting to curve. Like this. So we would say no.
I might be getting ahead of myself, but wouldn't there be a formula that can let us know by the numbers if it's linear or not?
Correct, and that should be next notes.
Yeah.
Next couple notes, yeah. Okay, and then lastly, plotting these points, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Is that linear?
No.
What is that called? Quadratic. So this is not linear, but this is quadratic, and we will talk about that not until the next unit. Okay. Okay, so I'm going to try to get through about 2 more of these problems. And this is the last topic of getting y by itself, so I'm going to go ahead and finish out the rest of it on the video instead of using class time next time. So number 19 Since we have x and y on the same side, this is called standard form. Okay. Standard form looks like ax plus by equals c, where the x and y variables are on the same side. We want to take these out of standard form and put them into slope-intercept form. Slope-intercept form is that y equals mx plus b. So all we're doing here is we're getting y by itself. So we're going to treat this like a multi-step equation. So we only want the y's on this side and then everything else on this side. X's and numbers, okay? So if we only want the y's on the left side, what are we going to do with that ax? Subtract it over. Is it going to combine with the 20? No, we're just going to have negative 4y is equal to negative ax plus 20. We always write the x's first before our constant number. And then what's our last step to get y by itself? Divide by negative 4. We're going to divide every term by negative 4. So that negative 8x and that 20. So we get y is equal to, what's negative 8x divided by negative 4? 2x. And then 20 divided by negative 4? Negative 5. So this is our answer. We took our standard form of ax minus 4y equals 20 and turned it into slope-intercept form y equals 2x minus 5. Why is this answer considered slope-intercept form? Good, because this number here is our slope, our m, and our b value here is our y-intercept. This is going to help us when we are graphing linear equations. Okay. I'm going to go ahead and do number 20, and then you guys are good to go. So on number 20, we want y by itself. So what are we going to move first?
The 2x.
So minus 2x, is it going to combine with the 12? No. So we have 3y is equal to negative 2x plus 12. And what's our last step? Divide by 3. Every term divided by 3. So I have y is equal to, can we simplify negative 2 over 3?
No.
No, so that means our slope is just negative 2 over 3x. What about that 12 over 3?
Plus 4.
Plus 4. And that's our answer. Okay. This concept is getting y by itself. So overall, this concept is called literal equations. These are literal equations. And we'll see this concept again later on with more variables. But this one, we're just getting y by itself. Bye, guys. I'm going to be staying on here and finishing the rest of the problems for the video. So if you don't have a class after, you're free to stay. Bye, guys. Yes.
I wasn't here last Wednesday, but I was doing the PEMDAS ones. I had a question. I kept getting like fractions like this and decimals. I wanted to kind of ask you if it's okay if I get decimals or fractions, or does it have to be specifically whole numbers?
No, decimals and fractions, that's fine.
Okay.
You will get decimals and fractions.
Okay, yeah, because I just wanted to make sure, because like I kept getting decimals and I was like, no, that's not right. I was like, I wasn't 100% sure. So decimals and fractions are completely okay.
Yeah, so usually you'll get the fractions if there's a bunch of fractions in your problem.
Okay.
They'll stay fractions. But if you have like some here where you're dividing like that 3 by 5,
Yeah.
you got a decimal, then they'll stay decimals.
They'll stay decimals. Okay, so if I get, so like on the test or anything, like if I do get a decimal or a fraction, it'll still be counted okay?
Correct.
Okay, so as long as they just show my work on how I got that process, that's okay.
Correct.
Okay.
Correct.
Okay. I just wanted to make sure before I get all confused.
No, that's perfectly fine.
Okay. Thank you very much.
Okay, thank you.
So for an exam on the 25th, it was topic 1 to 14, right?
For the 25th of October?
Yes.
Or the
September.
25th? It's 1 through 9.
1 through 9. Oh, okay. And then how many questions are there?
About 20
Oh, okay. Or do we take in person?
in person.
Oh, okay. Oh,
Yeah.
that's why I didn't see in module. Okay, thank you.
Yes, no problem.
Professor, I'm just gonna stay.
No, that's fine.
Mind if I come in and unload some?
Oh yeah, no problem. I'm just finishing the last couple problems for
Yeah, I
the
just
video.
have a whole bunch of
Oh,
goodies
yes.
here to unload for my basket. Students can do math if they're hungry.
Okay, so for 21, 2x plus y is equal to negative 11. We're getting y by itself. So I'm going to subtract the 2x over, and I get y is equal to negative 2x minus 11. Since the y is already by itself, that is my answer. Yep. 22. So for 22, same thing. I'm just getting y by itself. So I'm going to subtract the 0.8x over to the other side. And I get 0.4y is equal to negative 0.8x plus 1.2. I want to get the y by itself, so I'm going to divide both sides by 0.4, so every term. Okay. When I do that, I get y is equal to negative 2x plus 3. So when I actually put those decimals into the calculator, you're going to get the whole numbers. Number 23, before I get y by itself, I'm going to distribute that 2. So I have y plus 9 is equal to 2x plus 10. Then I'm going to subtract 9 to both sides, and I have y is equal to 2x plus 1. That's my answer. Again, when there's no numbers in front of y, we get our answer fairly quickly. And then the last one, number 24, I'm going to distribute that 2/3 first, and I get y minus 1 is equal to 2/3 x plus 2/3 times 3. So 2/3 times 3 over 1. This gives me 6 over 3, which is 2. Okay? So that means I have y minus 1 is equal to 2/3 x plus 2. Then I'm just going to add my 1 to the other side, and I get y is equal to 2/3 x plus 3. And that's our answer here.